Finding an element in a sorted collection. Hello everyone, so I'm hs.salami. I'm going to try to explain today the solution for finding an element in a sorted collection, which is considered as a common question during interviews, more precisely when applying to Google, Facebook, Amazon, Apple, Murex, and others. I don't want to specify anyone and I don't want to miss any company, but there is a lot out there. So let's start. You should know that usually during the interview, it is really recommended to ask clarification question, and also to try to rephrase the question, just to be sure that you are on the same line with the interviewer. In that way, you'll be able to find and to take some time to think about the solution at the same time. So how should you proceed? You should first start asking some clarification question. For instance, ask for some examples. You should try to rephrase the question that is asked. Okay? So let's start. Finding an element in a sorted collection. You will have to ask first about an example, for instance. The interviewer will tell you, let's take a collection. A equal to 1, 2, 5, and 7. It is sorted. And you have to try to find the value 5. So the answer would be the index 2, because the value 5 is present at the second position by taking into consideration that the index starts with 0. Okay, however, you can find directly an edge case here, or let's say a negative test case, which could happen, for instance, if the value is not present in the collection. And in that way, you should ask the interviewer, or you should propose the interviewer a choice. For instance, you can tell him that in that situation, when we don't find the value, we can return, for instance, an exception, which is also recommended, or maybe return an invalid value, which could be -1, because indexes could never be negative in a collection. That being said, so we have now the different examples. We are able to clarify. We understood how the solution should work. Now we should start thinking about the implementation. By default, a trivial implementation could be passing or iterating over the array and testing in each iteration if the value can correspond to the target value. If it is the case, you return directly the index. Otherwise, you continue your traversal. You will probably get an answer about that, and it is definitely a correct answer also. However, it's not optimized, and it's not the expected answer for the interviewer. So in that situation, what should we do? In which way should we think to reach the solution? So what you should know is that all the solutions are implemented throughout and using all your learning from your past experiences and from your degrees. For instance, data structures, algorithmics, and others. So in that way, you should remember and you should try to leverage all the things that you know about data structures and algorithmics to try to find a solution. And also, you should try to find and use the hints that are written in the question and that you were able to identify by dialoguing with the interviewer. So in that case, let's see the question again. So you have to find an element in a sorted collection. Sorted collection. I think that I know something about sorted collection. Do you remember the binary search tree? Do you know how it works, the binary search tree? And in that case, the binary search approach? The binary search approach, it's an algorithmic solution that consider that in each sorted collection, let's say, of data structure, if you want to find a value inside it, Since it is sorted, you could divide the problem of finding or searching for the value in two during each iteration. Do you know dichotomy? It is the same here. We are talking about the same implementation and algorithmic answer. So in that way, let's just imagine and try to remember a little bit what's binary search and how it works. Binary search principle consider that if you have an array of size n and you know that it is sorted, and if you want to search for a value, okay, you can start searching in the middle. So you take the middle element in that collection and you compare that value with the target value. If that value is greater than the target value, it means, and we are sure, that all the values that comes after that value are also greater than the target. So it does not make sense and it is useless to search in the right side of the value. So in that way, you are reducing automatically the searching problem in two. So instead of searching in all the array, you will be searching just on the left side this time. So by doing so, during every iteration, your problem will be divided by 2. So at the end, the complexity will be logarithmic complexity, which is far way better and optimized. Okay, so let's see the implementation together. Okay, so how should we proceed first? We should first decide and discuss with the interviewer about the contract. What's the function name, what's the return value, and what's the argument of the function. In our case, since we are trying to find an element in a sorted collection, so the return value would be an index, the function name, let's name it find, and the argument would be the array, so the vector, and the target value, an integer. So let's proceed. So as discussed, the algorithm consists of finding the element, the middle element first, comparing it with the with the target value. If it is greater, we are going to search on the left side, otherwise on the right side. And we are going to return and to repeat that logic recursively. So in our case, let's create a small static function or private function, let's say, which would be our recursive function. Okay, so let's name it find rec. It returns also an integer. Okay, find rec. It takes this time the array, the target, and two new attributes, which are int start and int end. So those two arguments would play and would decide and would let's say boundary the size of array that you are searching into each iteration. So let's say we have start and end. Okay, so let's implement logic here. Okay, so first let's get the middle index. So let's write int mid index equal to start plus end divided by 2. So in that way we have the middle index, and let's compare the value of this middle index with the target value. So if array of mid greater than the target, what does it mean here? It means that this middle element is greater than the target. So in that way we are sure that everything on the right is also greater. So let's ignore the right section and just focus on the left section. So in that way, and in that case, we should recall our recursive function, but this time the end index would be mid minus 1. So let's call return find rec array target start and mid minus 1. So this is the first case. The second case, if array of mid is lower than the target, so it is the same case, but this time we have to search on the right side. Okay, so this time we will say return find rec array target. It will be mid plus 1 and so we have a last case here, which is the case where we found the value and in that case, if array of mid is equal to target, we can return directly the middle index, so the mid. However, since we are working with a recursive function, we should think about the base case. It is the case when the function will stop calling itself again and again. So in our case, we should stop recursing when start is greater or equal to array.size, when the end is lower than 0, or when start is greater than end. In those three cases, we should stop returning anything and we should return -1 or our unhandled, or let's say our negative case decided value. So that's it for the solution. I hope you enjoyed and you liked and it was clear for you. Don't hesitate to add your comments, it's more than welcome. And we are going to add more questions and also a next version for the find an element in a source collection, which is more difficult and also common question during interviews. It will be finding an element, this time in a rotated sorted collection. So stay tuned and see you.